Similar shapes. Similar shapes are two shapes that are exactly the same shape but different size. We get similar shapes when we make a model of a real thing that is smaller or larger. Similar shapes are a map compared to what's in real life. One of the most obvious ones is when we enlarge a photo. Everything in the photo stays the same shape, but it's a different size. Similar shapes are either an enlargement, like here with the photo, or a reduction, such as when we take real life and make a picture that's a map. A model is usually a reduction from what's real, but sometimes you can make a model of a very small thing and make the model bigger. So our definition: similar figures have the same shape but different size. Similar figures can be enlarged or reduced, and mathematically, in similar figures or similar shapes, same thing, there's two things: matching angles are equal, and the ratio of matching, or the ratios of matching sides are equal. And we'll talk about what that means. But if I want to check if two shapes are similar, I need to know that matching angles in each of the two shapes are equal, and not that matching sides are equal, but the ratios of matching sides are equal. Now let's talk about what we mean by matching sides. Matching sides in these two shapes, let's call them A and B. In triangles, it's nice and easy. The smallest side on shape A matches the smallest side on shape B. So sides 1 and 2 are matching sides. The middle side length on A matches the middle side length on B. And the longest side on A matches the longest side on B. In some other shapes, it can be harder to tell what sides match, but they're the sides that, if you turned those shapes around so they were aligned, so if I'd turned A around and B around so they were in the same orientation, facing the same way, matching sides end up in the same position. Matching angles, again, are just the angles that end up in the same position. So these angles here in A and B are matching. Now we said that ratios of matching sides are equal. It's easy to look at angles and see if they are equal. Okay, they're both 90 degrees or something. And that's what we've got in here. We've got rectangles. All the angles are 90 degrees. So all the angles are obviously equal. But the ratios of sides, to check if shapes are similar, we need to find ratios of matching sides. So first we identify which sides match. In these rectangles, the long side in each rectangle matches, and the short side in each rectangle matches. A ratio is a comparison just like a fraction, and in fact we're just going to do fractions where we put the side from one shape over the side from the other. And it doesn't matter which way you go. I'm going to pick my pair of matching sides. I could do 6 over 4, or I could do 4 over 6 in this case, as long as when I did the other pair of sides, if I was going to put the biggest side on top, I'd do that for both of them. Or in my second example, sorry, my page glitched a bit there. Sorry, my second example here, if I've put the smaller side on top for the first ratio, I've got to put the smaller side on top for the second ratio. So either my first pair or my second pair would be fine, but I have to choose one or the other. Largest side for the pair on top or smallest side for the pair on top. Mostly it's easiest to do largest side for the pair on top, unless there's something about the question that says not to. And that would be when you're finding a reduction factor, which we're not doing yet. So, write the ratios, matching sides, largest side on top, and work out what that equals. Grab your calculator and do 6 divided by 4, and we get 1.5. That says the big rectangle is 1.5 times the length of the little rectangle. And we check the other ratios of matching sides. 1.5 divided by 1 is also 1.5. And if those are the same, then our shapes are similar, because they have matching ratios, equal ratios of matching sides. Let me just turn the page. Now what you have just found is called a scale factor. It's the enlargement or the reduction factor from one shape to the other. How do we know if it's enlargement or reduction? That's if we got smaller or larger. So if I started with shape A and changed to shape B, that would be an enlargement. But if I started with shape B and changed to shape A, that would be a reduction. So when you get asked for an enlargement factor, A to B, we can see that's times 2. And if we checked our enlargement factor, we get a pair of matching sides, and we get the ratio by putting the largest side on top. So an enlargement factor, the ratio large side on top, 4 divided by 2 is 2. And we can see that the length on B is 2 times the length on A. But for reduction, B to A, we can see that A is a half of B. We don't always see it this clearly, but we'll check that with the maths. The ratio has to be, for a reduction, the small side of the pair on top, and 2 over 4 is a half. So a side on A is half the length of a side on B.